grounding a subpanel is essential for safety and code compliance. Even though the subpanel is located in the same house as the main panel, it introduces a new grounding point. The National Electrical Code, often referred to as the NEC, requires that each service panel and subpanel have a separate grounding system. Firstly, safety is paramount. The ground rod and water pipe connection provide a path for fault currents to safely discharge into the earth, preventing dangerous electrical shocks and fires. Secondly, code compliance dictates that the NEC requires a grounding rod and water pipe connection for all service panels and subpanels. To properly ground the subpanel, follow these steps. 1. Install a ground rod. Drive an 8-foot copper-clad ground rod into the ground near the subpanel. 2. Connect to the subpanel. Run an insulated number 4 AWG copper ground wire from the ground rod to the ground bar in the subpanel. 3. Connect to the water pipe. Run a number 6 AWG copper wire from the ground bar in the subpanel to the water pipe where the main panel is connected. Use a ground clamp or other approved method to secure the connection. Make sure the ground rod is at least 6 feet away from the foundation. Use corrosion-resistant connectors and wire for all grounding connections. Inspect and test the grounding system regularly to ensure its integrity. The purpose of grounding is to provide a low impedance path for fault current to return to the source. This low impedance path facilitates the operation of overcurrent protection devices such as circuit breakers and fuses, which interrupt the flow of electricity during a fault condition, protecting people and property from electrical hazards. Grounding also helps to stabilize voltage to earth during normal operation and minimize electrical noise. The ground rod provides a direct connection to the earth, which serves as a reference point for electrical potential. The water pipe, being a metallic underground system, also provides a good grounding electrode. Connecting to both the ground rod and the water pipe creates a redundant grounding system, increasing its effectiveness. When installing a ground rod, ensure that it is driven deep enough into the earth to reach a low-resistance soil layer. In areas with dry or rocky soil, it may be necessary to use multiple ground rods connected in parallel to achieve the required resistance to ground. The NEC specifies that the resistance to ground should not exceed 25 ohms. This resistance can be measured using a ground resistance tester. If the resistance exceeds 25 ohms, additional ground rods should be installed. The size of the grounding conductors is determined by the size of the service entrance conductors. The NEC Table 250.66 provides the minimum size of grounding electrode conductor based on the size of the service entrance conductors. For example, if the service entrance conductors are number 2/0 AWG copper, the minimum size of the grounding electrode conductor is number 4 AWG copper. The grounding electrode conductor should be securely connected to the ground rod and water pipe using approved connectors. These connectors should be made of corrosion-resistant materials to prevent deterioration over time. It is also important to protect the grounding conductors from physical damage. They should be routed in a way that prevents them from being accidentally cut or damaged. In some cases, it may be necessary to install the grounding conductors and conduit for added protection. When connecting to the water pipe, make sure to connect to the metallic water pipe before any insulating fittings or meters. This ensures that the water pipe provides a continuous grounding path. The connection to the water pipe should be made within 5 feet of where the water pipe enters the building. If the water pipe is non-metallic, such as polyvinyl chloride, commonly called PVC, then it cannot be used as a grounding electrode. In this case, another type of grounding electrode, such as a ground rod or ground plate, must be used. The NEC also requires that the grounding electrode conductor be connected to the metal frame of the building if the building has a metal frame. This helps to ensure that the entire building is at the same electrical potential, reducing the risk of electrical shock. The connection to the building frame should be made using a bonding jumper. The size of the bonding jumper is determined by the size of the service entrance conductors. The NEC Table 250.102 provides the minimum size of the bonding jumper based on the size of the service entrance conductors. In addition to grounding the service panel and subpanel, it is also important to ground all metallic enclosures and equipment. This includes metal boxes, conduit, and equipment frames. Grounding these metallic parts helps to prevent them from becoming energized during a fault condition. The grounding conductors for equipment grounding should be sized according to the NEC Table 250.122. This table provides the minimum size of equipment grounding conductor based on the rating of the overcurrent protection device protecting the circuit. For example, if the circuit is protected by a 20 amp circuit breaker, the minimum size of the equipment grounding conductor is number 12 AWG copper. The equipment grounding conductors should be connected to the equipment grounding bar in the panel. The equipment grounding bar should be bonded to the panel enclosure. The NEC requires that all electrical work be performed by qualified personnel. It is important to hire a licensed electrician to install and inspect the grounding system. A qualified electrician has the knowledge and experience to ensure that the grounding system is installed correctly and safely. Improper grounding can create a dangerous electrical hazard. Fault current is the current that flows during an insulation failure or short circuit between a live conductor and ground, or any metallic part. In such a scenario, electrical current seeks a path to return to its source. If a proper grounding system is absent, the current might flow through unintended paths, like a person touching a metallic object. This can result in a severe electrical shock. A good grounding system provides a low impedance path for fault current, allowing a large amount of current to flow quickly. This high current triggers overcurrent protection devices like circuit breakers or fuses to trip or blow, cutting off the power to the circuit and preventing electrocution or fire. Impedance is the measure of opposition to alternating current, similar to resistance in a direct current circuit, but also considers the effects of capacitance and inductance. A low impedance path is desired in a grounding system, as it allows fault current to flow more easily. This can be achieved by using appropriately sized conductors and making sure connections are tight and free of corrosion. Grounding electrode conductors connect the grounding electrode like a ground rod or water pipe to the electrical system's grounding point, usually the grounding busbar in a service panel. The size of this conductor is determined by the size of the service entrance conductors, as specified in NEC Table 250.66. Equipment grounding conductors provide a path for fault current from equipment enclosures back to the service panel, facilitating the operation of overcurrent protection devices. These conductors can be wires, metal conduits, or other approved raceways. The size of equipment grounding conductors is determined by the rating of the overcurrent protection device protecting the circuit, as specified in NEC Table 250.122. Bonding jumpers are used to connect metallic parts together to create a continuous electrical path to ground. This includes bonding metal water pipes, gas pipes, and other metallic components that could become energized. Bonding helps ensure all metal parts are at the same electrical potential, minimizing the risk of electric shock. Ground clamps are specialized connectors used to connect grounding conductors to grounding electrodes, such as ground rods or water pipes. They are designed to provide a secure and corrosion-resistant connection. Ground rods are metal rods typically made of copper or copper-clad steel, driven into the ground to provide a direct connection to earth. They are a common type of grounding electrode and are required by the NEC for most electrical services. Water pipes, when made of metal and in direct contact with the earth for at least 10 feet, can be used as grounding electrodes. However, plastic or insulated couplings can interrupt the electrical continuity of the water pipe, making it unsuitable as a grounding electrode. The NEC, published by the National Fire Protection Association, is a widely adopted standard for safe electrical installation. It provides comprehensive requirements for grounding and bonding to ensure electrical safety. Understanding and following the NEC is crucial for anyone working on electrical systems. Resistance to ground is the measure of how well a grounding system is connected to the earth. A lower resistance indicates a better connection to ground. The NEC recommends a resistance to ground of 25 ohms or less. This can be measured using a ground resistance tester. Ground fault circuit interrupters, often called GFCIs, are devices that detect ground faults and quickly interrupt the circuit, protecting people from electric shock. GFCIs are commonly required in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, often called FSIs, are devices that detect arc faults, which are dangerous electrical arcs that can cause fires. FSIs are required in many areas of the home, particularly in bedrooms and living areas. Surge protective devices, often called SPD, are devices that protect electrical equipment from voltage surges, such as those caused by lightning strikes or power grid fluctuations. SPD divert excess voltage to ground, preventing damage to sensitive electronic devices. Regularly inspect the grounding system for any signs of corrosion, damage, or loose connections. Test the grounding system periodically to ensure it is functioning properly. Keep the area around ground rods and other grounding electrodes clear of obstructions. If you are unsure about any aspect of grounding or electrical safety, consult a qualified electrician. Never attempt electrical work if you are not qualified. Always turn off the power before working on electrical circuits. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves, when working with electricity. Be aware of your surroundings and avoid contact with any conductive materials. Follow all applicable electrical codes and regulations. Grounding is a critical aspect of electrical safety. A properly installed and maintained grounding system can protect people and property from electrical hazards. By understanding the principles of grounding and following the requirements of the NEC, you can ensure that your electrical system is safe and reliable. Remember that electricity can be dangerous. If you are not comfortable working with electricity, consult a qualified electrician. Your safety is the top priority.